things off. So yeah, we're the chemical engineering ambassadors, and we'll just tell you a little bit more about the chemical engineering department. Next slide. Okay. So these are kind of all the people that you'll get to interact with within the chemistry department. So of course we have the head of chemical engineering, Dr. Kim, and then also the different student services that you'll have. So we have Mrs. Raderstraff, Mrs. Morgan, Mr. Weigel, and Sandy Hendricks is kind of like the central hub of all things chemistry. She sends out the different emails and stuff. So these are all the people that you'll get to interact with a day-to-day basis. So this is kind of a rundown of the student profile within the chemistry program. We have about 342 total students, a pretty good mix of men to women. It's almost, we're getting there, we're getting better, 59% men, 41% women. Most people are actually non-residents of Indiana, which is actually kind of surprising. We have a pretty good international population as well. And then hopefully this will keep clicking through. 73.8% of the students within chemistry have a 3.2 or greater GPA, and 84.5% have a 3.0 or higher. About 34% of the students are active in research. I can speak on that a little bit. I did it last year in my junior year. And then a lot of people participate in co-ops and internships. We'll also talk about that, and study abroads as well. And then we have over 10 school-related organizations. So here's a rundown of the chemistry curriculum. It's not actually as chemistry-based as a lot of people think, which is almost disappointing sometimes, but it's a lot of kind of process and reactions based. So sophomore year, you'll take Chemistry 205, which is your introduction to chemical engineering. You'll get a feel for material balances and different stuff like that. And then everything kind of moves up from there, and they're all related to each other. So in addition to like the chemical engineering like major classes, we also do take biology, Orgo 1 and 2, we have physical chemistry, and then you have to go through all of the maths, all of the calculus, linear algebra, and DiffEq as well. And then we also have a lot of general educations that you can take just to get that full degree. And now we'll talk about enhancing your chemical engineering degree. Okay. So there are quite a few study abroad opportunities. We have it fall and spring, and you can pretty much go anywhere. You can go to UK, Germany. I know they have some maybe in Sweden, all over the place, and it's a great opportunity. They range from a whole semester, or you can go on little spring break or Maymester trips. You can earn from 3 to 9 credits, depending on which program that you want to participate in. You can take stuff that's actually chemistry related or general education classes as well. And it's a great time. Unfortunately, I didn't have an opportunity to do it, but I wish I did. Next up is research, which is something that I highly recommend that students do more in. We can talk more about that later. But if you literally just walk up to any kind of chemistry professor and ask them like what kind of research that they're doing and see if you can get involved, they would be more than happy to welcome you in. I did research with Dr. Harris in biomaterials, and it was a great time. I got some credit for it, and I also got paid for it, which is great. So definitely look into that. There are a couple of students who also participate in different concentrations. So we have 4 of them. There's pharmaceutical engineering, materials and polymers, energy and the environment, and then biological engineering. These concentrations aren't as big, but if you really know what you're passionate about within chemistry, then I would highly recommend getting more into these concentrations and developing that practice more. So if you want to go into grad school or a specific industry, you have that knowledge and strength behind you.
Hi everyone. Oh, sorry, I didn't mean to cut you off.
You got it.
My name's Alex Dobbins. I'm a senior in Chemie. So I'm going to talk about co-op. I actually just returned to campus from my 1 year stint on co-op. So within engineering, one of the really cool things are co-ops, which are, if you're not familiar with them, they're like internships, except you sign up to do multiple of them, and some of them take place during the semester. So for instance, last spring semester, last fall semester, I was co-oping and actually had an internship as well over the summer. So you can kind of pair a lot of them together. And basically the way it works is you go to an interview, you meet with a company and they make an offer to you. And they're a little bit better than internships because you are signing on for multiple sessions. You sort of get the opportunity to do more. A lot of the programs can be rotational. So if you look at Vantage on the screen there, that's where I co-opt, and their program is rotational. So I got to work in quality, R&D, technical production, and then also have a sales and marketing co-op as well. So not all companies will do the rotations like that. For instance, I know Sabic typically has a lot of their co-ops stay within like a maintenance role. Around a quarter of all chemies co-op, but co-op for all the students chemies actually make up almost half of all Purdue co-ops. And in addition to all the great work experience and learning you get from it, it pays pretty well, which is really nice. And it's also really fun sometimes to take a break from school and get a little bit of a taste of the real world. And before we go on to the next slide, I'll let Catherine chime in if she wants, because she's also a co-op student.
Hi, I'm Catherine, and I'm a junior in chemical engineering. I co-op with Eastman Chemical, so a little bit different than him because I co-op in Tennessee. So I did a rotation in research and a rotation in process, and then one in safety that I'm going to do this summer. So got to get experience a lot of different parts of the company, which definitely was the best part for me because I wasn't sure, what kind of area of engineering I wanted to go into. So definitely a great way to figure out a company, learn a company, meet a lot of different great people, and figure out where you want to go with your career.
Awesome. And if you guys have any questions more about co-ops or like internships, we can talk about it after this presentation. I'll just keep it pushing. So next we'll go into the different industries that chemies can go into. So the six main ones are consumer products, petroleum, food and beverages, energy and the environment, biotech and pharmaceuticals, and then high performance materials.
So consumer products makes up sort of a large facet of where a lot of chemies work. If you get your undergraduate, there's not a whole lot of opportunities to do research in kind of any of these fields. It can depend, but if you end up getting your undergrad in chemie at Purdue, a lot of people move into manufacturing, and that's sort of the world that I worked in at a specialty chemical manufacturer. So we made like the base material that went into skincare products, so shampoos and lotions. We also made like the chemical base that can go into some food stabilizers, that goes into like paints. And that's sort of one of the really interesting parts of chemical engineering is you get to learn about not what does the final product look like, but what do all the ingredients that go into that final product look like. And there's a surprising amount of like day-to-day materials that you can touch as a chemie.
And then of course, another one of the big industries is petroleum, which I think a lot of people associate with chemical engineering. So of course you have like Chevron and Shell doing a lot of the processes within there. I don't have much experience on it, but yeah, it's a big industry for chemistry. But I can talk about food and beverage. For the past 2 summers, I've interned with General Mills. They make like Cheerios, Gushers, Betty Crocker stuff. And I'll actually be doing research and development with them full time after this. So I highly recommend the food industry. It's a great way to, I don't know, you kind of see how the food you eat from day to day is made. And I find that really interesting, and being in the test kitchen. So yeah, if you guys have any questions, please let me know.
So this is energy and the environment, which is a really growing section of chemical engineering right now. This is actually what I'm doing my concentration in. So there's tons of places to explore in this field, batteries, solar panels, combustion reactors, all kinds of things. So, and there's a good example. So of Dr. Wong, who's doing oil by distillation to separate the oil into gasoline. And there's a lot of professors within the department who do different kinds of energy and the environment research. So huge opportunities right now in this field.
So I'll chime in a little bit about biotech. This isn't really a field that you can work in with an undergrad unless you're in, again, a manufacturing role. There's a lot of really, really cool science that's going on in this field, but a lot of it is sort of at the graduate and at the PhD level. But basically it's a way of like creating biofuels. Some of the petroleum companies have briefly tried to find like enzymes that will eat plastics and then create gasoline as a byproduct or similar to that. So this is more of an emerging field in chemical engineering. And this is definitely one that if you're interested in would be great to talk to a professor about, because a lot of the professors do research that touches this industry or this side of industry.
And then last up, we have high performance materials. So this is like materials that are used in industry to make commercial products that we use every day. You could even with Adidas, different shoe products, Nike and stuff like that. This is also an industry I'm not too knowledgeable about, but I feel like it's like innovation on the cutting edge and different stuff like that. And then we're pretty much wrapping it up. These are the top hiring companies within chemical engineering. And these are definitely not all of them. There's so many more. But yeah, I would say you can pretty much work wherever you want. IR is a huge time, I mean, for all engineers, but especially in chemistry, you can pretty much get wherever you want. And yeah, the average starting salary for chemistry is around 76,000, which is pretty good. And that pretty much wraps up our presentation. Do you guys have any questions? Do you want us to go back to a slide? Feel free to ask.
There was one question about co-oping. Let's see if I can scroll up to that one. Could Alex and Catherine talk about their experiences with the co-op? What did you do day to day? Were you in a lab? What did you do on computers? What was the hardest part or the part you didn't enjoy? Catherine, you want to go first?
Yeah, I'll pass that one right back to you. My co-op was actually supposed to start last summer, and I'm supposed to be on rotation right now, but with the pandemic, both of mine got pushed, so I'll actually start in the summer.
Gotcha. So I've completed 4 co-op sessions, and like I said, mine was rotational. So my first session was in a quality lab. So I guess a little bit more in depth of what I did there is I took some of the longer, more old-fashioned wet method chemistry tests that we had, and we got a near-infrared spectroscopy machine, and I tried to create real-time lab data based off of products we're making in the plant, and then create a predictive algorithm in the near IR machine to cut down plant time, because running something on a near IR takes 5 minutes and running it on the old-fashioned wet chemistry way takes 2 hours. So it was a way that we could speed up the plant. I also worked in R&D, which was also in the lab. And there I helped a PhD synthesis chemist create base formulations for lotion. And that base formulation goes into J&J or SC Johnson. I don't know. It's jojoba products. So it goes on like face creams and skincare lotions. So that was really cool. The best part of about that was I learned that I'm not someone who's super interested in R&D. Let's see. My 2 longest sessions were in the plant. So working as a technical, working on the technical team, so which is more longer term equipment focused, and then production, which is more day-to-day focused. So in terms of like production, I helped with quality issues, or I helped plan activities with maintenance, like lockout, tagout. Everything you really need to know is on Excel. Some companies will have specific programs they use. Like I know some of the paper companies have their own software specifically for like paper machines. And the hardest part, the real world can be kind of tough. Like I remember learning to cook. I definitely gave myself food poisoning once making chicken. It can be really weird, like leaving and coming back. So this is my first time back in a year, and having to start learning chemical engineering again, and also try and learn how to do this online. That's been a little tricky for me. Um, I guess I'd say kind of like with that too, one of the hardest parts is it's pretty easy to lose touch with people when you're off campus. But you definitely learn who like your real friends are really quickly. And I would recommend getting into like some clubs or some orgs because it makes keeping in touch with people so much easier. So that was a lot of information. So let me know if you want to hear any more. So there's another question from Hannah. It says, do you know the biggest difference between chemical engineering with a biotech pharmaceutical concentration and biological engineering with a pharmaceutical concentration? I don't personally know this one, Christina or Catherine.
That is a great question.
Yeah, that's really interesting. The only people I know who are biological engineers usually work in like agriculture kind of field. So I'm not sure biological with a pharmaceutical focus, if that would be similar.
I would say I have a friend, she's an undergrad on a PhD track for chemical engineering, and she's doing the 1 year internship with Eli Lilly starting, I think it's either this summer or next year. So some of the pharmaceutical companies have reached out to Purdue about starting co-ops. And I know specifically they're looking for chemies. So if that helps, that might be a question also to ask the ABE school and kind of see what they have to say about that as well. Okay, so looks like we answered Hannah's question. And then we got a question, how does the 5 year master's degree program for Chemi work? Specifically to the Chemi department, I'm not entirely sure, but from what I know about a lot of the accelerated master's degree programs you take is you finish up your undergrad degree like a semester early, and then you start taking graduate classes basically just faster than you would normally. And it's a fairly rigorous and condensed schedule. I don't know if anyone else has anything to add to that one either. I know it's doable. I don't know a whole lot of people who choose to do it though.
Hello, everyone. I'm Alan Reigel. I'm one of the academic advisors in chemical engineering. Just to kind of touch base on that, thus far, we have not had any students pursue the 5 year Chemi MBA 5 year program. If that's the one you're talking about, I'm sorry, the 5 year master's program. We do have some students that are doing that. It's starting to that you incorporate graduate work towards the end of what would be your 4th year. You're going to start getting into more of the graduate work, but you cannot. And then you graduate, as Alex said, and then you continue on with strictly graduate work. So there's a little bit of an overlap with that, but you apply during that 4th year to get into the program, and then continue on to earn the BS in, or I'm sorry, your MS in chemical engineering. We have one that's also similar that we've teamed up with the Krannert School of Management that would get the MBA in 5 years. That's one we have not had any students take part in just yet because of the intensity of that. As any of our students will tell you, there's a lot of intensity and many other things to branch out in within chemical engineering undergraduate as is. But essentially, with you doing that MBA program, that that 5th year is all MBA programming. And then that final semester, you're also putting in the chemical engineering design course so that you're ending up with everything at the same time. I think the one thing that some students have said that why they've elected not to do the MBA right away is because when you look at the average age of MBA programs, they tend to be about 29 years old. So you're teaming up with individuals who have been in the professional work place for 5, 6, 7 years when they come back into that MBA program. So there's, while it's very interesting dynamic for students to work with, sometimes it's a little bit of a different approach for them to do that. But we do have some students that are doing that MS program within chemical engineering. But again, most of the students that tend to pursue graduate school, at least particularly right away, are those who are going to end up really wanting to either do strictly research, or they are going to go on to a PhD to then go into the teaching aspect of it, which a lot of our students, at least going through the undergrad, many of them have more aspirations of going into industry, trying their hand out at several maybe different industries, but getting out in the workforce and doing that way, because then many companies will support employees to go back and get their masters as well. So. Yeah, the one thing too, I just was going to kind of touch on what Alex was saying is that we are in works with Eli Lilly to solidify the 1-year long internship program. This is kind of even new for Eli Lilly. Typically, they've only done internships over summers. They do not participate in co-op programs. So if they did, I can guarantee Purdue would be at the top of the list. But the 1-year program is going to be, again, where you've typically gone through the sequence of coursework and have gotten through the 3rd year of your undergrad with getting through our 348, 378, that would be reactions and heat and mass. And then you would be gone for 1 full year with your internship and then return for your final year. So it's almost kind of like taking that break in there to get all that work experience. But chemical engineering is a natural fit into pharmaceuticals. So again, some students will do that concentration in pharmaceutical engineering, but then many others will branch into other aspects of taking courses that could also be helpful, that aren't in the concentration, but still be a very natural fit into chemical engineering. I talked from one of my friends who recruits at Purdue for Eli Lilly. She was a chemistry major here, but now she oversees 120 people at Eli Lilly out of Indianapolis. And she says they recruit heavily for chemical engineers. And that's really kind of what they really focus on. What are you all most passionate about in chemical engineering? Anybody?
I can take that one, I guess, to start. I really like sort of the broadness. When someone asks you, like, what does an engineer do? It can be like sort of very difficult to answer. My parents have still been for years trying to figure out like what I did on co-op. So if you're someone like me where I'm a senior now and I'm still sort of wondering like what exactly do I want to do after college, a field like chemi is really great because there is so much you can do. You can work in food manufacturing, you can work in chemical manufacturing, you can work in gas and oil, you can go to grad school and work in pharmaceuticals. So there's really just about anything you could want in terms of the field of engineering, between the research, the manufacturing. There's even consulting companies will hire engineers. That's a little bit more of a business focus. So that's really nice. It just gives you the flexibility. And then within that too, like there's locational flexibility. So you can sort of move around the country or even the world.
And I'll follow up with that one. So I would say like I found my passion while going through chemi. So when I first came in freshman year, I wanted to go in biomedical engineering. And then I realized that I could still do biomedical stuff within chemi. So I made that switch because like Alex said, it's like a lot more broad. And then that's when I really found my passion for like food, which is how I got into General Mills because I don't know, I've always liked cooking. It's something that I did as a hobby, as a pastime. So it just allowed me to focus and find a career path and company that I really love. I mean, I've interned with General Mills twice, so like I found, yeah, I found my career path. So it's been great.
So I'm gonna have to tag on to Alex a little bit. So I found my passion in chemical engineering with actually the research that I joined, which is through the mechanical engineering school. So I love how broad chemical engineering is and how it could really take you anywhere. So I never expected to be like passionate about a mechanical engineering lab and what they work on and what they do, but it's kind of given me this idea to maybe go to grad school with it. So I've been looking into that a lot, but so I just love the way that chemical engineering could really take you anywhere.
Yeah, I can also follow up. So I joined a little late, but my name's Holly. I'm also a junior in chemical engineering. I also interned with General Mills with Christina, and I worked in food safety and quality. And I chose chemical engineering because I've always wanted to work in food. So I think like I also second what people said about it being very versatile. And if I decide 10 years from now that I don't want to work in food anymore, I can go and do something completely different. And I think that's exciting because you're not boxing yourself into a specific industry.
Anyone else have anything to add or any other questions? No? All right, well, if Kemi doesn't have anything else, I'm going to go ahead and put up the QR code so we can get attendance.
Oh, there's one more question, and Alan, this one might be a little bit better for you. If the basic chemistry classes are hard for someone, should that be a deterrent for this major or this field?
I think most students would probably also be able to kind of jump on that. Chemistry, as mentioned early, is not the main focus. There's certainly going to be some aspects that you're going to have to understand, and that is why we do have our students go through the two general chemistries of 115, 116. You are going to take organic chemistry 1 and 2, and then you do physical chemistry. Which we often call PChem. The reason why for those essentially though is that again with the diversity of industry that you can go into, the multitude of different positions that our graduates go into, that there are going to be times where you have to be able to communicate with chemists. I think a lot of the feedback I get from our students is that it's more so that you can understand and have collaborative efforts with chemists in a particular company more so than you having to be able to rely on your chemistry. So is it important or should it be a deterrent? No, because a lot of it's going to be more focused with being able to do the mathematics and analytical components of it, and some physics with that. So you'll find that if those are your strengths, then chemical engineering is certainly I think a good fit for you. I think it can be misleading by the name of being chemical engineering that everything is going to be chemistry, which is certainly not the case. I don't know if anybody's had different experiences than what I've just kind of stated that might help them feel a little bit more at ease about making that kind of a choice.
I would say that's pretty par for the course. Chemi is very math and science heavy. So like in Chemi 205, you really just sort of learn an entirely new way to solve problems. And then as you move through your later Chemi classes, you basically just add physics and math to that until you can really do just about anything that a Chemi would want to have in their tool belt. And from the time that I worked in R&D, I worked side by side with a PhD chemist, and he was able to explain everything to me. And I really didn't need to know like the specifics of the chemistry for my day-to-day job in manufacturing either.
And I think that's kind of it, where in some of these companies, you're going to have the chemists that are kind of playing around with the different compounds, like say in pharmaceuticals, they're going to be creating the different compounds of the new uh, medicine or the drugs. But where chemies come into play in something like that is how do we take that formula and now be able to produce and make the company money essentially. How do we make the business and get that product out to uh, the greater population without destroying the compound of that material that you're working with. So yes, there is some understanding of that, but don't let that be a deterrent. It's going to be, again, how do you recalculate that to a grander scale from that one particular aspect. So yeah, definitely don't let chemistry, if it's not your thing or your favorite, you got to get through a couple more classes, but then you get to go and have fun with math in a lot of different ways. These are good questions. If anybody else has anything else.
What I can do, I'll put up the QR code and then we can hang around for a few more minutes and answer some questions. Okay. What do people see? Do they see my presentation mode or the PowerPoint itself?
We see the PowerPoint.
Okay. So here's the QR code. If you're having issues with scanning, just leave your name and Purdue email in the chat. I'll go ahead and record all of that. If you have an iPhone, you should just be able to get your phone out and scan it. I think if you have anything else, you need to have an app for it. But I'll leave this up for a few minutes. Then if there are no questions, once you've taken the survey and logged your attendance, you're free to go.
Well, we appreciate everyone's time to learn a little bit more about chemical engineering. I know it's not everything, but hopefully it just kind of gives you some sense and basis of what it is, kind of putting some faces with chemical engineering, our ambassadors, a little bit of their experiences, and we appreciate your time. So, and good luck with the spring semester. As far as no other questions rolling in. Oh. How hard is chemical engineering to get into compared to other engineering schools? A lot of it is always dependent on the pool of applicants with the numbers. But as of late, even though we are kind of in the upper 40% in terms of size of school, we've been very open to really getting most people in as long as you have met the FYE requirements with grades and the GPAs, not always necessarily cutting it off at the 3.2. So when I say that, 3.2 would just guarantee you the admission into chemical engineering like any other program. But we've been lenient based on numbers and interest and with the freshman class. So it's really kind of more of analyzing or assessing yourself and where you feel like your skill sets are in terms of the academics and where you see yourself going career-wise, the flexibility you would like to have in careers. But we are quite open to the numbers that would apply through the T2M process. Good. Does that spur any other questions?
So if there's no other questions, I think we're probably good to go.
Okay.
All right, well, Kemi, thank you for your time. Appreciate
you.
it.
Thank you for hosting, Andrew. Appreciate it.
Yeah, no problem.
Thank you, ambassadors, and go get some supper now or something, and enjoy the rest of your evening. I appreciate you all being here and giving your insights and your experiences and everything else. So, yeah, good to see everybody's faces too. All right, everyone, take care. Have a good night.
All right, have a good night.
All right,
Bye.
bye-bye.